Howdy everybody. 2-7 today, applications of proportions. Now, this is one of my favorite sections. You get to draw really cool pictures and things. Hold on just a second, I got a phone call. Okay, as I was saying, 2-7, applications of proportions. I really like this section. You get to draw pictures, it's a lot of fun. We have 3 vocab words today, similar figures, and those are 2 figures that have the same shape, but they aren't necessarily the same size. Okay? Remember probably from, I don't know if you've learned this term yet, but congruent means same shape and same size. But similar means they have the same shape, but they're probably not the same size. Now within similar figures, we have something called corresponding sides and corresponding angles. Corresponding sides are sides on 2 different figures that are in the same position. Okay? And I'll show you what this means here in the next slide. And then the same thing's true with corresponding angles. Okay, you have 2 figures, and corresponding angles are the angles that are in the same relative position. So in order for 2 figures to be similar, they have to meet 2 qualifications. Okay? 1, all of their corresponding sides have to be proportional. Okay, and we'll talk about what that means here in a second. Also, all of their corresponding angles have to have the same measure. So it has to pass those 2 things before we can say that they are similar. So let's take a look here at 2 figures. Now these are nice and color-coded, which they won't all be for you in the book, but this is to give you an idea of what we're looking at. So here I have these triangles, ABC and DEF. Now AB and DE are corresponding sides. You can see that they're in the same spot on each triangle, and they're both blue in this case. So here I would set up a proportion between AB and DE. That's what this is over here. Then I do the same thing. BC and EF are corresponding sides. They're in the same spot. So I set up a proportion for those. And then finally here we have AC and DF. Those are corresponding. I set up a proportion for those. Now if these 2 figures are similar, all 3 proportions will be equal to each other. Then I check the angles. Again, they're color-coded here, but you could figure it out if they weren't. A and D are corresponding. They have to have the same measure. That's what this M means. B and E are corresponding. They have to have the same measure. C and F are corresponding. They have to have the same measure. Okay? If both of those things are true, we say the triangles are similar. And when we state that, we use a symbol that looks like this little squiggly thing right here. Okay? That means similar. So for the triangles in the example we were just talking about, we would write triangle ABC is similar to triangle DEF. Now one thing you have to make note of when you're writing a similarity statement, and that's what this is called. This is called a similarity statement. Is that you have to put corresponding angles in the same spot when you name the triangles. So if you'll notice in my similarity statement that I'm drawing a square around here, A and D are corresponding angles. They both come first. B and E second, C and F third. So it would be wrong if I wrote something like this down here, ABC similar to EFD. Okay, I have to have the letters that are corresponding in the same spots when I name the triangles. That will also help us when we're trying to find missing side links, which is kind of the main purpose of what you're doing today. So similarity statements are key in knowing which sides and which angles are corresponding. So let's take a look at our first example here. This is what you'll see. You'll have 2 shapes and then a similarity statement. Now I have triangle MNP similar to triangle STU, which means I know they're similar, which means their sides are going to be proportional. So it looks like here ST, they tell me that that side is 4. Now I'm just going to set up here ST is corresponding with MN. And I know that because they're both first and second in the similarity statement. I can also kind of see that from the picture. That should be the same as SU, which corresponds to, let's see, these are first and third, so MP. Okay, so what I'm going to do now that I know that these should be proportional because they're corresponding sides, I'm going to put in my values. So ST is 4, MN is 6. SU is X, MP is 14. Okay, now from here it gets pretty easy because I'm going to use the same skills that we learned in 2-6. I'm going to cross multiply. So I have 6x equals, and 4 times 14 is 56, I believe. Okay, 40, yep, no, yes, 56. So then I got to divide by 6. And let's see, 6 times 8 is 48, 6 times 9 is 54. So looks like I'm going to have 9 with 2 6 left over, which is 1/3. So X would be 9 1/3 centimeters. Okay? Let's look at another example of the same type. Now this one's a little bit harder because the shapes aren't sitting in the exact same position like they were in the previous example. But again, I look at what I know. So I know AB, and I can see from my similarity statement that that corresponds with FG. And again, since these are similar, their sides should be in proportion. I also know DC. I can see from my similarity statement that that's going to correspond with JH or HJ, it doesn't matter. Okay, so now let's put our values in. AB is 10. FG, I don't know, that's X. DC is 14. And JH is 3.5. So then again, all I have to do to solve this, cross multiply. So I have 14x equals 35. I'm going to divide by 14, and let's see, it goes in there twice with 7 left over, so 7/14 is a half. So FG would be 2.5 inches. Okay, so that'll be the first part of your homework, is taking two similar shapes and finding missing side links. Now here's the fun ones. Okay, we have story problems, which I know you all love, and we get to draw pictures. Okay, that's awesome. So we have a flagpole that casts a shadow 75 feet long. So let's draw our flagpole here. And here's its shadow. Its shadow is 75 feet long. At the same time, a 6-foot man, let's draw us a little dude. He's 6 foot tall. Cast a shadow that is 9 foot long. Write and solve a proportion to find the height of the flagpole. Okay, so if we make these into little triangles here, they're going to be similar triangles. So I'm going to set up a proportion using corresponding sides. Now the height of the flagpole and the height of the man are corresponding sides, so x over 6. Then the lengths of the shadows. Now notice I put x and 75 both on top because they come from the same triangle. That's very important. And then 6 and 9 are both on the bottom because they come from the same triangle. Once I get the proportion set up, again I'm just going to cross multiply. So I have 9x, and then 6 times 75 I believe is 450. And then I'm going to divide by 9. And that comes out to be 50. So I know that the flagpole is 50 foot tall. Okay? And that's how, again, I would show my work. I'd draw my picture, write my proportion, and solve it. Let's look at one more here. We have a forest ranger who's 150 centimeters tall. So we draw a little dude and put a forest ranger hat on him. And he is 150 centimeters. And he casts a shadow that's 45 centimeters. Then at the same time we have a tree. Let's draw ourselves a tree. That is, well, we don't know how tall it is, but we know it casts a shadow that's 195 centimeters long. Write and solve a proportion to find the height of the tree. So the height of the tree is x. Now again, if we make these into triangles, they're going to be similar triangles. So I'm going to write a proportion again. So I have 150, that corresponds with x. And then 45 corresponds with 195. Now again, notice, put 150 and 45 both on the top, 45 and, x and 195 both on the bottom. So the forest ranger triangles on top, tree triangles on bottom. Now again, I'm going to cross multiply. So I have 45x equals 150 times 95, or times 195. Let's see what that is. 29,250. And then to solve, I'm going to divide by 45 to figure out that the tree is 650 centimeters tall. Okay? So those are the two types of problems you'll be running into today on your homework. As you work through your book work. Okay? And again, exactly how I showed my work in here is how I'm going to want you to show your work when you do it on your assignment. We'll see you guys tomorrow.